Okay, very good morning, students. Today we can continue our topic of physics, that is the gravitation. So, yesterday we have learned the effect of gravity of the different parameters that we want to learn, but we have learned how the G depends upon particularly different factors. Okay, you have learned the equation for gravity also, and I think so the equation for the gravity G is equal to gm by r square. So that things we have already calculated, because if any body is thrown vertically upward direction, so then it will falls towards the earth's surface only due to acceleration due to gravity. And acceleration due to gravity works because of the gravitational force acts on the body, and that F is equal to g m1 m2 upon r square. And if I put the value of F is equal to m into g, okay, and then after calculating all these things, then we are getting the point G is equal to gm by r square. So that expression we have learned. Okay, so now today we can continue that point, expression for the acceleration due to gravity at a particular height h. Okay, now here in that case, suppose this is the earth surface. Okay, this is the center of earth, and now if I will consider r is the radius of the earth, and this is any body having the mass m, which has been kept at a distance of particular height h above the earth's surface. Okay, acceleration due to gravity at this point is supposed to be gh. Okay, so that relation which we have calculated yesterday, that is acceleration due to gravity on the surface of earth, g is equal to gm by r square, where g is acceleration due means, that is your capital G is the gravitational constant, capital M is the mass of the earth, r is the radius of the earth. So that is the equation number 1. Okay, but now if I want to find out the acceleration due to gravity at particular point of, that is the height h, okay, above the surface of earth, so then now this distance we have to consider into account. No doubt that h is, we have to be comparable to r, or it is very less than r. So these are the two different conditions. First of all, we can consider, suppose that height is comparable to r, so then gh we want to write down. So that is equal to capital G by m. Okay, G is the gravitational constant, m is the mass of the earth, and now that will be r plus h bracket square. Why? Because if I'll write down the force m into g, mm will get small, m will get cancelled. Here also the same thing is going to happen. So therefore, I will write down the second equation directly. That is gm upon r plus h bracket square. This is the second equation. And now if I will divide this equation 2 by 1, divide equation 2 by 1. So now as soon as we will divide that equation, then what you will get, gh upon g is equal to gm upon r plus h bracket square into r square upon gm. Now if I cut that gm, then what equation will be there remains, r square upon r plus h bracket square. Or we can also say that gh by g is equal to, what is gh? Acceleration due to gravity at particular height divided by acceleration due to gravity on the surface of earth is equal to r upon r plus h bracket square. And therefore we can also say that gh is equal to g into bracket r upon r plus h bracket square. Okay, so that is the expression for that your acceleration due to gravity at particular height. So this expression which we have already wrote r plus h bracket square, so that is gm upon r plus h square upon gm by r square. So therefore r square upon r plus h bracket square. Okay, so this expression particularly we can use when your height above the surface of earth is comparable to r. So then you can definitely use this relation. So this is the relation, that is the third relation, or you can use this relation also at particular height if it is the height is comparable to the radius of the earth. Okay, and once you got that relation, how that gh is equal to g in bracket r plus h square, Then we want to find out the variation of G due to height, depth, shape and rotation of Earth. Okay, so we want to learn the different parameters. Hope so you got this expression. Okay, you have learned all these things, and then we want to learn the effect of, that is your different parameters. Okay, so can I rub this now? Yes. Okay, so please we can proceed for the next point, as we have already learned these factors. So effect of effect. Which are the effect or variation of G due to height, depth, shape. Okay, variation of G, we can say effect of height. Instead of that, we can say variation of G due to height. Variation of G due to height. Okay. Now suppose this height is not comparable to the radius of the earth. This height which we are considering, it is supposed to be, here in that case we can consider the same thing. This is the earth's surface having the mass m, having the radius o, and any object which has been kept at a distance above the surface of earth is at a distance of height h. Okay, the G will be acceleration due to gravity on the surface of Earth. So that we have already calculated. But now suppose at this particular point I want to find out the acceleration due to gravity. Then sir, how we can do that things? So then now my question is now here, sir, as G we have calculated, that is the Gm by R square. This is the first equation. Okay. How G is going to vary with respect to that height. So acceleration due to gravity on the surface of Earth is Gm by R square, where G is the gravitational constant, M is the mass of the Earth, R is the radius of the Earth. Okay, so that things which we have been calculated. Now once you got that G, then suppose if I want to find out acceleration due to gravity at particular height h, so then now this equation again I will say Gm upon R plus h square. So suppose this is the second equation. Okay. So now once you got that both this equation, again I will divide the first equation to that second equation. Okay, dividing equation 2 by 1. And similarly, how we have calculated the last equation, same thing. Divide equation 2 by 1. So therefore, I will say GH upon G is equal to Gm upon R plus H square, and divided by Gm upon R square. That equation can also be written as Gm upon R plus H bracket square into R square upon Gm. Gm will get cancelled. So therefore, acceleration due to gravity at a particular height h is equal to R square upon R plus h bracket square. So that is equal to, so your R square upon R divided by 1 plus h by R square. I will proceed for the further this equation like this. So R square upon R we can take out. So therefore this equation will becomes like this. Okay, that is the R into R, just we have taken common, h by R, that is raised to 2. So therefore that is equal to GH upon G is equal to GH upon G is equal to R square upon, here that is the R square in bracket 1 plus h by R bracket square. R square will get cancelled, and so therefore this expression will becomes GH by G is equal to 1 plus h by R raised to minus 2. And if I solve this further, this equation, GH upon G is equal to 1 plus h by R raised to minus 2 means 1 minus 2h by R. Which equation, which formula I have used? Binomial theorem. 1 plus x bracket raised to n is equal to 1 plus nx into, that is the higher order terms of that x, or that is x. So now here the higher order term for h by r, so that your h is very small as compared to r. So therefore we have neglected all these terms, and so therefore this equation will becomes gh upon g is equal to 1 minus 2h by r, or acceleration due to gravity at one particular height h is equal to gh is equal to g in bracket 1 minus 2h by r. So that will be the your expression. Here in that expression, naturally I will say, as h is goes on increasing, means you are going above the surface of earth, then acceleration due to gravity goes on decreasing. Okay, so that is the one of the equations that we have been calculated. Okay, so you remember here, again I will remind to you, when you want to, that means calculate the acceleration due to gravity at a height h, yeah, if the h is comparable to r, h is comparable to r. Comparable to r means that distance, whatever the height which you have been given, is in terms of kilometers. Okay, means near about 6400 kilometers, or approximately in very large kilometers. So then at that time I will use the second equation. Use the second equation to calculate the acceleration due to gravity. But second, if h is very small as compared to r, म्हणजे मुलांनो h खूपच कमी आहे, म्हणजे 100 meters, 200 meters, 1 meter, 2 meters, like this in meters. So that is not in kilometers also. H is very less than r. Then we are using this equation. Suppose this is per second, and I will give the name to that equation as a third equation. Use third equation. Okay, म्हणजे मुलांनो जर तुम्हाला एकदम h कमी असेल तर हा तिसरं इक्वेशन वापरा, आणि जर तुम्हाला जर h खूप कंपेरेबल टू r असेल तर दुसरं इक्वेशन वापरा. ओके, सो दॅट इज द कंडिशन फॉर दॅट युअर h. ओके, so once you got that acceleration due to gravity, okay, that means, but in the both the equations you have learned, as the h goes on increasing, acceleration due to gravity goes on decreasing. Now I want to explain the expression for the acceleration due to gravity at a depth of h or d below the earth's surface. But before proceeding to that equation, I will give you just one problems on that. So how we can calculate the acceleration due to gravity in case of that particular height. So what equation has to be used here? So you please take the example. I will give one or two example to you to solve this question. Okay, so the write down first example. I will say, suppose find the altitude. Okay, can I rub this now, bachalo? Okay, I will rub this all these things, and on this equation that these two expressions are there, we are able to solve the questions on that. Okay, so take numericals. Some numericals we can solve now, one or two, and then we'll go for the variation of g due to depth. Okay, so that second factors we want to learn. Okay, so now we can calculate the numerical. Okay, first numerical, find the altitude at which, find the altitude means h we want to find out, at which acceleration due to gravity gh is 25% of that surface of the earth. Okay, means he has asked to h, but what the height 25%. Acceleration due to gravity at height h will be 25% of acceleration due to gravity which is there lies on the surface of earth. Okay, so that is the relation. म्हणजे मुलांनो हाईट वरती तो किती झाला रे, 25% ऑफ जी झालेला आहे. ओके, and r is equal to 6400 kilometer. R is equal to 6400 किलोमीटर. मुलांनो हा GH किती दिसतोय बघा बरं, 25×100 1/4 टाइम्स G. म्हणजे हा जर R तुमचा 64,400 किलोमीटर होता आणि त्याचा 1/4 पार्ट वरती, म्हणजे इट इज कंपेरेबल टू द R. Okay, H is comparable to R. So therefore, if I want to find out the height, at what height, so my expression I have to consider which is comparable to R. काय एक्सप्रेशन होतं मुलांना ते सांगता येईल का तुम्हाला आता? GH is equal to GM by R plus H. R plus H. Okay. R plus H ब्रॅकेट स्क्वेअर. हे बघा, हे पहिले एक्सप्रेशन आहे मुलांना. आणि एक दुसरं एक्सप्रेशन तुम्ही लिहिलेलं आहे, GH by G is equal to, or G is equal to GM by R square. So therefore GH by G is equal to GM cancel होऊन जातो मुलांनो, R square upon R plus H bracket square. Or we can also say that R upon R plus H bracket square. Okay. आपण हे कंपेरेबलला हे एक्सप्रेशन वापरलं होतं मुलांना. मग तुम्हाला काढायला काय लावलंय? EH काढायला लावलाय. GH upon G पण इथे त्यांनी देऊन ठेवलाय मुलांना. किती दिलाय पगार येतो? That is GH upon G is equal to 1/4. Okay. मग मी काय करतो मुलांना, हा GH by G 1/4 इथे टाकून देतो. हा R upon R plus H. R plus H. R plus H आणि ह्याचा होल ब्रॅकेट स्क्वेअर आहे मुलांना. दॅट इज द होल ब्रॅकेट स्क्वेअर. दॅट इज इक्वल टू 1/4. मग मी आता याला सोडवायचं जर असेल तर मी काय करेल, याचं स्क्वेअर रूट घेऊन टाकेल, म्हणजे तुमचं उत्तर इथे येईल. हे बघा हा मुलांना, कसं काढणार मी आता बघा. R upon R plus H is equal to taking the square root on both sides, that is 1/2. So therefore 2 times R is equal to R plus H. 2 times R is equal to R plus H. And what we want to find out? H. So therefore H is equal to 2R minus R, or therefore H is equal to R. H is equal to R. मुलांनो H is equal to R जर असेल तर R ची किंमत आपली किती टाकली होती तुम्ही? 6400 किलोमीटर. 6400 किलोमीटर. So therefore H is equal to the radius of the earth, means comparable to this. Okay. आणि मग मुलांनो मीटर मध्ये जर ही हाईट मला पाहिजे असेल तर त्याच्या MCQ मध्ये उत्तर होतं 6.4 into 1 2 3 हे आणि 10⁻³ म्हणजे हे 10⁶ मीटर. सो therefore correct option is 6.4 into 10⁶ मीटर. सो that is the right answer. Okay. चला मुलांनो अजून एक गणित तुम्हाला दुसरं. Okay, so we'll solve this example. If you have wrote like this, then we can go for the second question. Okay. So can I rub this now? Yes, sir. Okay. Now second question that we want to solve. Okay. So please write down next question. At what height from the surface of Earth will the value of G reduce by 36% from the value at the surface? Okay. G will be reduced. म्हणजे त्याने तुम्हाला GH is equal to GH. Second problem. GH is equal to what percent? G minus 36% of G. एवढं तो त्याने काय झालाय? रिड्यूस झालाय. पहिल्या याच्यातून तो G 36% एवढा रिड्यूस झालाय. तर ती हाईट किती असेल? तर व्हॉट विल बी दॅट हाईट? आणि त्याने कंसात परत देऊन ठेवलाय R is equal to 6400 kilometer. R is equal to 6400 kilometer. Okay, so this is the another question. So now if I want to find out acceleration due to gravity at a particular height h, okay, so then now here gh is equal to g, if I will take common, 1 minus 36 upon 100. So gh is equal to g 36. Okay, now 36% what he has done, that is the less at that particular point, means 100 minus 36, that is the 64. Okay, कारण मुलांनो 6 plus 4 10, 6 plus 3 9 10. Okay, 64% of g will be left, or gh by g will be 64 upon 100. राहू द्या मुलांनो याला असं. आणि हे सुद्धा कंपेरेबल टू आर आहे, म्हणजे आपले इक्वेशन तुम्हाला बदलावं लागणार नाही, म्हणजे यू कॅन हॅव टू कीप द सेम इक्वेशन. सो देयरफॉर आय विल से as gh upon g is equal to r upon r plus h bracket square. तेच इक्वेशन ठेवू मला. याच्यात त्या किमती टाकू आपण. gh by g will be 64 upon 100, that is equal to r upon r plus h bracket square. Okay, so therefore r upon r plus h is equal to under root of 64 upon 100, that is the 8 by 10. 8 by 10. Once you got that 8 by 10, so now I have the r with me. So 2 4s are 2 5s are 5r is equal to 4r plus 4h. 5r minus 4r is equal to 4h. So therefore r is equal to 4h. So he has asked you find out the h. So therefore h is equal to r by 4. And what is the r now here? R will be, how will take 6400 kilometer, and then I'll put this value 6400 divided by 4, and so that is equal to 4 ones are 4, 4 6 are 2, 4, means 1600 kilometer. Okay, it is comparable to radius of the earth. म्हणून मुलांनो, your answer will be 1600 kilometer. Okay, 1600 kilometer should be the right answer. Okay, मग बोलून अशा प्रकारे आपल्याला कोणतेही एक्सप्रेशन आलं तर आरचं हे इक्वेशन टाकायचं, त्याच्यावरनं त्याचं ते कंपॅरेबल जर असेल तर ते इक्वेशन मध्ये डायरेक्ट त्याची व्हॅल्यू टाकून द्यायची मुलांना. ओके, पण जर सर समजा तो एच खूपच कमी असेल हां, आणि तुम्हाला जर त्याने तसा प्रश्न तयार केलेला असेल तर मग सर कोणतं इक्वेशन वापरायचं. ओके, मग हा पण एक प्रश्न आपल्याला आढळू शकतो. मग तसा एखादा प्रश्न घेऊ मुलांना आपण. सो प्लीज यू राईट डाऊन. फाइंड द व्हॅल्यू ऑफ जी at a height of 400 kilometer above the surface of earth. आता बघा मुलांना, आता हा जो प्रॉब्लेम आहे 400 किलोमीटर, म्हणजे हाईट इज 400 किलोमीटर, which is not comparable to r, means this is very very less than r, म्हणजे 6400 किलोमीटर कुठे आहे हा कुठे, म्हणजे h is very very less than r. सो आणि त्याने तुम्हाला त्या पॉइंटला आता त्याने काय विचारलं, फाइंड द व्हॅल्यू ऑफ जी विचारतोय मुलांना. मग आता आपल्याला हा एच किती येईल माहिती आहे का, 4 into 10⁵ मीटर येईल मुलांना, आणि आपल्याला त्या पॉइंटला हाईटला आपल्याला काय काढायचं आहे, जी एच म्हणजे ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी काढायची. मग असा जर प्रश्न आला तर मग याला कसं सोडणार सर, मग आपल्याकडे आता ते इक्वेशन आहे, जी एच इज इक्वल टू जी इन ब्रॅकेट 1 मायनस 2h बाय आर. याला जे आपण पुढे सोडवत जातो ते इक्वेशन इथं वापरा मुलांना. ओके, इट मेक्स नो डिफरन्स बट इट इज व्हेरी स्मॉल. सो देयरफॉर gh is equal to g in bracket 1 minus 2 times h किती घेणार आता, 4 into 10⁵, आणि आपल्याकडे r आहेच मुलांना 6400 into 10⁵ मीटर. म्हणजे आता तुम्हाला जर याच्यात जर समजा जी ची किंमत तुम्ही किती टाकून दिली रे, ऑन द सरफेस ऑफ अर्थ जी इज 9.8, आणि तो जर तुम्ही 9.8 टाकून दिला मुलांनो तर उत्तर तुमचं किती येतं बघा रे. हे जर तुम्ही 9.8 टाकला GH is equal to 9.8 आणि मग याला जर सर्व सॉल्व केलं 1 मायनस हा 4 जुने 8 म्हणजे हा 10⁵ आणि 8 8 64 आणि इंटू 10⁵3 तर युअर आन्सर विल बी ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी इज इक्वल टू 8.575 8.575 meter per second square. Okay, 8.575 meter per second square. So that will be the acceleration due to gravity. म्हणजे मुलांना कोणत्या ठिकाणी कोणता फॉर्म्युला वापरायचा. सो जस्ट यू रिमेंबर. आता आपण एक्सप्रेशन फॉर ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी आता आपण इन्स्टेड ऑफ ॲट हाईट h आय विल टेक ॲट द डेप्थ. ओके ओके म्हणजे मुलांना त्या डेप्थवरती आपल्याला त्याचं एक्सप्रेशन आता नोट करायचं आहे. ओके सो नाव आय विल रब होल दिस थिंग्स ॲट द हाईट आपण खोडून टाकूया आणि त्या ठिकाणी आपण डेप्थकडे जाऊया मुलांना. ओके व्हॉट विल बी द एक्सप्रेशन फॉर दॅट डेप्थ. ओके तर आता आपण त्याला फास्ट कॅल्क्युलेट करू मुलांना की व्हॉट विल बी द एक्सप्रेशन फॉर दॅट डेप्थ. ओके तर आता मुलांना पहिल्यांदा आपल्याला त्याचं एक्सप्रेशन फॉर द डेप्थसाठी जायचं असेल. ओके तर पहिल्यांदा आपल्याला काय करावं लागेल बघा. ओके एक्सप्रेशन फॉर द डेप्थ. ओके तर पहिली गोष्ट आपण आता एक्सप्रेशन फॉर द डेप्थ बिलो द अर्थ सरफेस. एक्सप्रेशन फॉर ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी. ओके एक्सप्रेशन फॉर ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी at a depth d below the surface of earth. At depth d below the surface of earth. Surface of earth हे आपल्याला काढायचं आहे म्हणून. Acceleration due to gravity at a depth d below the surface of earth. मग सर आता हे कसं काढणार सर. आता आपण याला एक काम करू याची डायग्राम एक तयार करू. ही रेडियस होती. ओके ही रेडियस आर आणि एक आपल्याला समजा आपण ही जर एक अर्थ घेतली आणि याला आपण डग करत गेलो आणि ह्या डेप्थवरती म्हणजे ह्या डेप्थवरती ती बॉडी ठेवली आपण असं गृहीत धरू. आता म्हणजे इथं ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी जी होती ही डेप्थ होती. मग तुमची ही जी इथला पॉइंट असणार आहे हा पॉइंट आपण याला पी म्हणू. मग हे जे तुमचं समजा मुलांना हे टोटल रेडियस जर अर्थची आर असेल तर ही एवढं डिस्टन्स किती येईल रे आर मायनस डी. एवढं डिस्टन्स ओ टू टी आर मायनस डी. ओके सो दॅट विल बी द डेप्थ. ओके और आर मायनस डी. आणि जर मुलांना इथं अर्थचं मास जर एम घेतलं तर बिलो डेप्थ दॅट विल बी एम डॅश. ओके सो दॅट विल बी ऑल्सो consideration. So and this is the again radius of the earth. मी आता याला काय करेल मुलांनो आता at this on the surface of earth I know the acceleration due to gravity that is gm by r square. हे पहिले इक्वेशन मी लिहिलं. पण मुलांनो मग आता ह्या केसमध्ये ह्या मासला मला डेन्सिटी आणि व्हॉल्यूमच्या फॉर्ममध्ये लिहावं लागेल कारण तुम्ही ज्यावेळेस डेप्थला जाता त्यावेळेस त्याचा काय बदलून जाईल मुलांनो तो तुमचा व्हॉल्यूम चेंज होईल. म्हणून आता मला इथं बट डेन्सिटी इज इक्वल टू मास अपॉन व्हॉल्यूम. सो मास इज इक्वल टू डेन्सिटी इंटू व्हॉल्यूम और डेन्सिटी इंटू 4/3 पाय आर क्यूब. सो दॅट विल बी द मास ऑफ दी अर्थ. मग ती जर व्हॅल्यू इथे टाकली तर मग जीचं एक्सप्रेशन तयार होईल जी इंटू रो इंटू 4/3 pi r cube upon r square. R cube will get cancelled. G is equal to 4/3 pi r rho into g. Okay, so that will be the expression. Means G is directly proportional to R. If the density gravitational constant 4/3 pi is remain constant. So R is directly proportional to, so G is directly proportional to capital R. Now this is the first expression which we can say. So this is second expression. Now if I want to find out the acceleration due to gravity at a depth d, so then that gravity depth will be gm dash upon r minus d square. तिथे रेडियस किती घ्यायला लागेल मला मुलांनो डेप्थला r minus d square. ओके, मग आता मला m dash पण काढावं लागेल मुलांनो. सो देअरफॉर m dash is equal to rho density into v dash. So m dash is equal to rho into 4 by 3 pi r minus dq. ओके, मग ती व्हॅल्यू इथे जर टाकली मुलांनो तर ही जीडी चे इक्वेशन तयार होणार. ग्रॅव्हिटी ॲट अ डेप्थ विल बी g into rho into 4 by 3 pi r minus d raised to 3. Okay, upon r minus d square. मग मुलांनो r minus d square r minus d हे कट होऊन जाईल. मग इथे काय राहणार माहिती आहे तुमचं, that is equal to 4 by 3 capital G rho pi into r minus d. म्हणजे मुलांनो acceleration due to gravity is directly proportional to r minus d. याला आपण तिसरं इक्वेशन म्हणून टाकू. चला म्हणून हे थर्ड इक्वेशन. मी आता काय करतो, डिवाइड थर्ड बाय फोर्थ. ओके, डिवाइड इक्वेशन third by fourth, third by second. Third ला आपलं d चे इक्वेशन आहे मुलांना acceleration due to gravity upon third ला second ला acceleration on the surface of earth is equal to r minus d upon what we can say बच्चे लोग, g is directly proportional to r, means r minus d upon r. Okay, so that directly I will write down this expression. So therefore expression acceleration due to gravity divided by acceleration due to gravity on the surface of earth is equal to 1 minus d by r, or d is equal to g into 1 minus d by r. So that will be the expression for acceleration due to gravity at a particular depth d. Here what we have observed बच्चे लोग, so d here as the depth will be goes on increasing, acceleration due to gravity goes on decreasing. Okay, so that will be the expression. So d is directly proportional to gd is equal to, okay, so that is d is increases, gd will be goes on decreasing. So how it will be depends upon the depth that we have. Okay, d increases, gd will be decreases. Now sir, I want to find out the relation of depth and height. So how they are related with each other. So now if I want to find out like this, so you have learned the two equations. Okay, first equation which we have learned is the acceleration due to gravity. Okay, acceleration due to gravity at a particular height h will be, what was that relation? G into 1 minus 2h by r. And at the depth you have learned g into 1 minus d by r. And sir, at the depth and height where the acceleration due to gravity will be remains same. If this is the question, then what I will do, g into 1 minus 2h by r is equal to g into 1 minus d by r. G will get cancelled. So 1 minus 2h by r is equal to 1 minus dr. So 1 will also get cancelled. Minus 2h by r is equal to minus d by r. Minus sign will get cancelled. R will get cancelled. D is equal to 2h. Okay. Means at the depth you have to go at the 2 times height, or h is equal to d by 2. Okay. जे वरती तुम्हाला d च्या हाफ जावं लागेल आणि खाली तुम्हाला 2h म्हणजे हाईटला तुम्ही जर 10 मीटर गेलात तर डेप्थला तुम्हाला 20 ला गेलात तर तुमची जी कसा असेल सेम असेल. मुलांना ह्या डेप्थ वरून अजून एक गोष्ट आपल्याला कॅल्क्युलेट करता येईल की सर व्हॉट विल बी द ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी ॲट द सेंटर ऑफ द अर्थ. At the center of the earth, at the center therefore acceleration due to gravity is g minus r upon r. So that is equal to 1 minus 1, and that is equal to 0. So acceleration due to gravity at the center of earth will be 0. Therefore, if you want to calculate the weight of the person at the center of the earth, then W is equal to M into G at that depth, okay, which is R. So therefore that will be M into 0. So therefore weight will becomes 0. Okay, तर ते weight किती मुलांना तुमचं 0 असेल. Okay, so that will be the condition. म्हणजे आपल्याला त्याचं weight depthला आणि heightला आपल्याला नोट करता येणार आहे. Okay. नंतर आपल्याला व्हेरिएशन ऑफ जी चे फॉर्म्युले बघायचे आहेत मुलांना. हाऊ दॅट व्हेरिएशन ऑफ जी विल बी देअर. ओके, सो बट इफ द टाइम परमिट्स. ओके, if the time is not there, so then we can, okay, so I'll give the last point to you how the variation of g will be there, okay, with respect to r. तर मुलांना तुम्ही त्याचे दोन एक्सप्रेशन नोट केलेले आहेत जी आणि r चं. तर आता समजा मी जर असं म्हटलं की फॉर एक्झाम्पल इफ आय विल से सर acceleration due to gravity, so that means at the surface of the earth, so gh upon g is equal to, so what you have learned, gh upon g is equal to, so what you have learned, that is the r upon r plus h, okay, bracket square. If r plus h is equal to r, means r is greater than h, okay, height r is greater than h, okay, म्हणजे तुमचा r जर हा कॅपिटल r पेक्षा कसा असेल मुलांनो, जास्त असेल, r ने तो जास्त असेल, ते एक्सप्रेशन कसं दाखवेल रे, gh by g is equal to r square upon small r square. So therefore gh is equal to gr square upon r square, or gh is inversely proportional to r square, means as the r goes on increasing, gh will be goes on decreasing, and that will be the parabolic path. Okay, so that is the first condition. And the second condition, if I will say at the depth, okay, so the your expression for the depth will be gd upon g is equal to gd upon, as the gd is equal to g minus acceleration due to gravity at the surface of earth will be 1 minus d by r. Okay, so that is your expression. And if I will say capital R is equal to, because capital R is equal to r plus d, capital R is equal to r plus d, means r is less than capital R. अगर वो अंदर है बच्चे लोग, r is equal to capital R is equal to r plus d, or small r is equal to r minus d, small r is equal to r minus d. So what will be that expression then? So I'll write down that expression, then that will be gd is equal to g in bracket 1 minus r minus d, r minus d, because I want to write down about the d, depth is equal to r minus r, depth is equal to r minus r upon your capital R. And if you solve that expression, g into r minus r upon r, okay, so minus minus it will get plus, so therefore gd is equal to gr upon r, or gd is directly proportional to r. So if I plot the graph of that your gd and g on the surface of earth, okay, so what will be the nature of the graph? So that will be the last expression, okay. And so if I will plot the graph of, that is the acceleration due to gravity versus distance, okay, so the nature of the graph will be, so suppose this is the distance and this is the acceleration due to gravity. So below the surface of earth, means this is the that means near to the surface of earth, acceleration due to gravity will be goes on increasing, means r increases, gd will be goes on increasing. Okay, so there is a direct variation is there to the depth. So at this particular point means I will say R, capital R is equal to capital R is equal to small r. Okay, or small r is equal to capital R. Both are the same. And here this is the depth. Okay, this is the depth. Means if you are going from, that means on the surface of earth, that acceleration due to gravity will be maximum. So here that will be the gravity will be maximum acceleration due to gravity. Maximum g will be on the surface of earth. Below that gravity will be goes on decreasing. And above EH means here in this side we can say that at a height outside the earth's surface, here at the height EH, acceleration due to gravity will be that means goes on decreasing, but this will be the parabolic path. Okay, how this path will be there? So that will be parabola. Okay, so that will be the nature of the graph. That is a particular height. Okay, so you just remember that will be the your nature of the graph. So most of the time they can ask you these questions. So this graph is here linear. Okay, linear. Acceleration due to gravity is directly proportional to r. This is the inside the earth surface. Okay, so and here it is outside the earth surface. Okay, outside the earth surface. Okay, so that will be the nature of the graph. Okay, so here we'll stop here. Okay, so this will be the O, and here that at the center of the earth acceleration due to gravity will be 0. That is the center of earth. Center of earth. Okay, so tomorrow we can see the acceleration due to gravity, due to that is the shape of the earth. So that we'll see tomorrow. Today we'll stop here.